Alright, welcome to the video on calculating the proper output direction vector from a shape collision. The reason we're doing this is because, let's go ahead and pull up MS Paint, and if this is our ground, which is not quite flat, but if we had a bullet coming in or something colliding and hitting at this angle, something that we see quite often just as a fast result that gets things out there really quick is just to kind of create a uniform dome emission of particles being created, which is not really what happens during an impact like this. There's more force, there's all kinds of formulas, and there's some kickback, but the majority of the force is kind of down and in this direction, and so we get a reflection of debris that is more oriented out forward from this. So what we want to do is actually look at what's going to happen when this ball hits. Right now we have those kind of simple little collisions occurring just in order to get some debris going, but in order to make those debris look better, we're going to want to give them some proper reflected direction. And actually in the script operators directory we have a video, script op 5, which talks about the reflection direction script operator that we actually created, which is really going to do most of this work for us. This video is just going to be putting that into practice. So here in our scene we've got a shooter object that fires some bullets, which are in the red, that big red particle. And then when there's an impact between the collision environment, which is the blue box ground, and the bullet, whenever there's a collision between those two and the velocity of that bullet is greater than 80, when all those conditions are true, it's going to go ahead and create some smoke at that collision position. And what we want to do is we want to modify this smoke direction to take into account this bullet's trajectory and get the proper kind of reflected direction, or at least something that looks better than a simple uniform spreading out like that. So let's go ahead and just drop this script in there. It's an operator under M3D tutorial called reflection direction tutorial, and it's got these parameters. Hit position's pretty easy, that's going to be the collision position. Hit normal, same thing, collision normal. But the incoming direction, that's a little bit different. We have to remember that when a particle has entered this dynamic set and has already been calculated by the SC, all of these outputs are only going to show us the result of that shape collision. So in order to get the incoming direction, we need to store this particle's direction before it gets into this rule. So that's pretty easy. We just create a new dynamic set. We'll call this store data. And what we'll do is on the bullet, we will just use a memory operator, and we will store its direction. Drop that there as an input, and because this is an actual direction data type, we can go ahead and just connect that to the particle, and it will derive or extract that direction from the particle. You do not have to expose the velocity and calculate that anymore. That's all taken care of automatically. A nice little feature in TP4. Okay, so now we have, and remember the way the sample tree works, for every sample, and in our case our sampling right now we're at per half frame, so for every half frame that we move forward, TP is going to evaluate down this tree. The bullet's going to go ahead and store its current direction that it's going. The SC is going to do its calculation. So when we're here inside the SC now, and we have stored our direction in the previous rule, we can go ahead and access that direction that was just stored one rule earlier. So we can access that for particle B, which is our bullet particle, and we can access that direction that it was traveling before it got into this SC rule, and we can go ahead and pipe that into the incoming direction. Okay, and then we can go ahead and take the reflection direction, feed that into our position born direction, and that's going to go ahead and tell those particles then You can't quite see it there. Let's give them a little more speed. And okay, well, we'll do a little comparison before and after. So let's look. In the second bullet, there's a big amount of colliding, and so we see that fanning out in that direction. It's set, the variation's a little high. You might do 45 or something. Boom, boom, boom. Okay, so you get the idea. And you can see it there in the top view as well, kind of fanning out. Okay, but you compare that with the result that it had been, where you just get kind of full dome, uniform kind of spray. That kind of spray behavior is going to end up looking a little funky. Definitely study reference. You can see the reflection direction, or that kind of direction momentum in the reference imagery and videos. And actually there's some really interesting patterns that occur based on the impact point and kind of horseshoe looking designs around that impact point. And you do sometimes get some splashback too, of course. But okay, so that's just an implementation of the reflection direction that we created in that script operator for reflection direction, and getting that into the SC world so that we can actually see our dust kicking up kind of in the right direction. Okay, let's move on.